This session will provide the introduction to various geometry building concepts such as geometric kernels, geometric entities, unit convergence. With the with using the COMSOL multiphysics software, we will demonstrate the advantage of creating selections, the usage of the various geometric operations such as the Boolean, partition, form union, and form assembly. We will also discuss how to use the geometric sequence, geometric part, and part library. We will walk through various geometric operations that are specific to the CAD import module and design module, such as defeaturing, repair, thickness, and all additional features. So yes, with this, let me start my session. And if you have any question, please feel free to type them in the question tab. We will answer this question in the end of the session. So COMSOL Multiphysics provides a unified umbrella to cover all the real world phenomena. The real world phenomena has the multiphysics aspect, whether it could be like electromagnetics, fluid, heat, structural, or chemical reaction engineering, acoustic. All these multiphysics phenomena you can consider, you can model with the help of COMSOL Multiphysics. If you have your own user defined equation based modeling is also possible. You can link to other platforms such as Livelink for MATLAB, Livelink for Simulink to work with the third party software as well. You can also create the application out of your modeling environment so that you can distribute that application within your organization. With this, many of us are actually the COMSOL users who might have seen the graphic user interface. Here you will find the definition, geometric materials, physics, mesh and study, and result nodes. So basically, we follow top to bottom approach. When I say top to bottom approach, there what I mean, first we will create the geometry and later, subsequently we will reach out to the results. This webinar series is based on the best practice, and here we are going to cover only on the geometric section. But our future webinars will also cover each of these nodes for the best practice. With this, let me introduce some of the geometric building concepts. So here we will talk about the geometric entities that COMSOL environments talk about, the units and the modeling environment it provides, such as the solid and the boundary modeling, and how to use the form union and form assembly operations. So COMSOL multiphysics do provide the various geometric kernels such as the COMSOL kernel, which is best suited when you are creating the geometry for the with the help of COMSOL software environment itself. So what basically the geometric kernels is consist of? It keeps the track of the mathematical representation of the object. So let's say if you have built a parabola, if this parabolic equation will this parabolic curve will remain parabolic, or it will be get converted into the spikes. So that kind of information will get stored into the with the help of geometric kernels. Note that if you are dealing with the any CAD geometry, in that case the parasolid kernel is also available, typically known as the CAD kernel, which which is available when you have the CAD import module, design module, or the Livelink products for the CAD. So various geometric objects and entities, if I talk about that COMSOL environment frequently use. Suppose if you are dealing with the 3D space dimension, in that case, the volumetric entity will be considered as the domain, the surface will be considered as the boundary, and subsequently the edges and points. If you are dealing with the, let's say, the 2D environment, in that case, your surface will become the domain. entity, and subsequently the all all geometric entity nomenclature will be followed. One interesting feature COMSOL do provide is the unit conversion. So suppose, first of all, the COMSOL multiphysics provide various unit for formulation. Whether if you are interested in dealing with the MKS system or CGS system or any other standard system, so that definitely you can choose. And after choosing that, you can select the length units, whether it could be meter, centimeter, as well as the angular unit, whether it could be the radian or the degrees. COMSOL multiphysics do provide the scales value while changing the units. So let us discuss how we can use this entity, this checkbox. So let me open my COMSOL environment. So first of all, I can follow the model visa steps. Let's say I'm dealing with the 2D environment. Let us click on the done. As of now, I'm not interested in any of the physics. So here, under the component, here you can find all the unit systems such as global global system, that is standard MKS system, then CGS system or the British engineering units. All these you can choose from here. Another option here, we have the geometric shape function. So basically, if you are dealing with the curved environment, curved geometry, in that case, as the COMSOL multiphysics is the FEM based tool, this curvature will become discretized. And suppose this, how you would like to have the geometric shape function, here you can definitely define whether all the no the elements, the shape between the two elements, whether it could be the quadratic one or linear one, can be defined with the help of the geometric shape function. By default, it is the automatic one. If you are using the single physics, in that case, the whatever the discretization typically used for that physics will be used for the geometric shape function. Next thing, here you can see you can choose for the length units as well as the angular units. Let's say I'm creating one square which has the unit of 1 meter, and I am clicking it on. So here you can see all the here we have built the square of 1 millimeter cross 1 millimeter. But let's say I want to design, I would like to go for the another unit system. In that case, if I directly go to my, let's say, millimeter, and I click on this geometry, here you will find now our square has nothing but the 1 millimeter cross 1 millimeter. So here you can see the original 1 meter cross 1 meter geometry has been reduced to the 1 millimeter cross 1 millimeter. If you want to retain this, you can click on the scale values while changing the units, and I can convert into the it into the, let's say, meter. And here if I click on, you will find now our original geometry was 1 millimeter cross 1 millimeter. It has been retained here itself. So here you can see the side length has also been modified. Next step comes to the geometry creation. So COMSOL multiphysics uh, has the two types of modeling. So first of all is the solid modeling. Here you will create the domain, you can create the Boolean operation, and your final geometry will be created. The next operation could be to create the boundary modeling. Here you will define the edges or the bounding element, and you can convert it into the solid one. After creating your geometry, the next step comes to the geometry finalization. Here, two options are provided, such as the form union and form assembly. If I talk about the form union option, here you will see after clicking on the form union option, the separate let's say the overlapping area is there, the separate domain will be created. You can This form union option basically provides the uniformity in case of the geometry as well as while applying the physics at the interfaces. There is another option also to go with the form assembly. So here you can see after finalizing our geometry with the help of form assembly, you can see the domain has been retained. No additional domain has been created at the overlapping area. This typically form assembly feature is useful when you are dealing with the specific kind of boundary conditions such as joints, contacts. If here you want to have the relative motion. So I can say the form assembly provides one additional flexibility as compared to the form union, so that you can modify your boundary condition at at the overlapping area. So talk about the let me talk about the with the help of demonstration itself. So suppose I have created my geometry with 1 millimeter cross 1 millimeter square. So here now you can see I have created my geometry as a 1 millimeter cross 1 millimeter, and there is a next additional geometry. Let's say one again the second square, and let me choose let me displace at the 1 millimeter. So here you can see two objects are there, two domains are there, which are having the adjacent length to it. If I click on the form union option, there you will find now this has been created the form union. So basically, if I apply the material, let's say the air for this square also and air for this square also. In that case, this this boundary become transparent in case of handling the physics. But if I go for the form assembly operation, in that case, I will need to provide the specific boundary condition for the overlapping or the adjacent area. It could be the identity pair. So similarly, as the function as transparent to the physics environment, or it could be the contact pair. So suppose you are sliding this one box in the positive y direction and this block in the negative y direction. In that case, this one edge from this boundary, from this square, and the common edge from this block will be having different movement. In that case, the contact pair type you can use, and you can create on the build on. And here under the definition, you will find the contact pair has been created. And later, you can use this contact pair for your assigning the boundary condition. So suppose, let me tell you, so if I'm going with the form assembly, you can also visualize the edge elements. So suppose if I click on the geometric show elements and I click on the, let's say, the boundary elements. So here you will find that the common edge has been labeled with the two different naming. That is the fourth boundary corresponding to the square 1 and the fifth number of boundary corresponding to the square 2. If I would have created the form union operation, you will easily notice now the common boundary has been labeled only with a single case. With this, if I build the meshing, so here you will find the meshing is uniform. Even if I go for the finer meshing, let's say let me add the size domain, and here I want to have the finer meshing in this region. I can go and click on the finer, and let's say build all. And let me add another rectangular mesh. So here now you can see the finer meshing has been allocated only for the domain 1, which was desired, and for the domain number 2, it is the normal meshing. And if you observe, with the help of union operation, the mesh element at the edges are consistent. But let's say, suppose I'm dealing with the, let's say, the with the help of finer mesh element, build all. Here also the consistency, the mesh element is consistent at the boundary. But let me go with the form assembly section. Suppose I click all, and if I choose the meshing for a, if I choose the build all, so here you will find the meshing is continuous. But let's say I'm going with the extra finer mesh for this domain number 1 only. If I click on the build all, here you will find now there is not overlapping between these. It is not, mesh nodes are not actually the consistent one. So yeah, form assembly basically is provides the additional flexibility while applying the boundary condition, but at the same time you will need to have the appropriate meshing condition also. So let me go back to my demos presentation. So I hope when this part was clear. So if I once again if I recap this section, so form assembly is preferred when you are going to have relative motion between the two domains. If not, you can go with the union operation. And form assembly provides you the flexibility to apply the boundary condition as per your requirement, whether the equation that we are solving, whether it will be the consistent or not. So that uh, at the given interface, or the dependent variables that you are calculating while solving the physics will be consistent or not, that additional flexibility is provided by the form assembly. So let us go for the various operation definitely that you can provide with the help of geometry, such as the Boolean operation, transform operation. So various Boolean operations, suppose you want to create this object, you can create the intersection of a block and sphere. You can also create the union of three different cylinder having the different orientation, and you can create the difference to get this final object. So all these Boolean operations can definitely used. You can create array out of your modeling environment with the help of various transform operation array, whether it could be the like say a circular one or could be the linear one. You can create copy, mirror, move option, rotate option. Additional feature that COMSOL multiphysics here provide is the building your object, building your geometry with the help of methods. So method is nothing but the programming environment where you will create the geometry by writing the lines of codes. This is typically preferred if you are dealing with the, let's say, the geometry which has some pattern. If you are designing the, let's say, Hilbert curves or the fractal curves, which are typically used in the while designing the filters or electromagnetic filters. So there, this automating your geometry building becomes useful. So not only this, you can also create the selections. So here at the time of creating the boundary itself, at the time of creating the geometry itself. So these selections can be like age selection, or it could be the domain selection, and later these selections can be used to assign the material properties or boundary condition or the domain condition in a one go. You can also create the Boolean operation on the selection. It could be union, intersection, or difference. or it could be the complement. Not only this, COMSOL Multiphysics also provide part library, which are the collection of frequently used geometries, and these are actually the fully parameterized geometry, which includes the coils, heat sinks, lens, RF connectors, bolts and beams for your the geometries which you use frequently. Let us have the demonstration how we can create this part, geometric part, and later we can use, and how to create the geometry with the help of the method or by writing the codes. So let's say, let me create another new instance. Suppose I'm dealing with the 2D environment for the simplicity. So here you will find under the geometric definition, you will find geometric parts. I can go for the various parts which are available, I can also create, or I can also call from the part libraries. So suppose if you are dealing with the RF connectors, in that case, various SMA connectors or surface mounting devices are present. If you are dealing with the structural mechanics, various bolts and beams which we use frequently are also available. That is the also case with the, if you are dealing with the AC/DC module, homogenized multi-ton coil, or the generic shape are also available. Let's say if you want to create the part from your which is not present in the part library. In that case, you can go under the global definition. You can go under the geometric parts. And here, let's say I'm dealing with the 2D parts geometry. So I will click on the 2D part. I can create let's say I'm interested in having the square of, let's say, side 4, 4 meter. It could be at position at the center. Then next thing, here, suppose this square is consist of the circles. These circles could be in the linear fashion or could be in the rotating fashion. I can also provide the if-else condition to execute them. So let's say if the circle numbers n, let me define it as the by default as a 2, and if this number n is greater than or smaller than the 4, in that case I would like to have the circle should be present in the linear fashion. In that case, I can go if else and if else condition, and here I will write the condition n should be less than 4, and here I will call the circle, let's say the radius of 0.1, and I have created my circle. It could be in linear fashion as I was talking about. Then with the help of transform, you can create the array. And here, let me create the array of this circle. And it has the size of, let's say, n cross n. And the displacement in the x direction, let's say the 0.3 meter, and in the y direction, it should be like in 0.3 meter. So in a one go, I have created the linear circle. Now, if I increase the value of square, if I increase the value of, let's say, 4, in that case, this statement will not be get executed. So as this condition is become failed. Now let us go with the another if else condition. Let's say if if the n value is greater than 4, in that case I would like to have circles in the circular fashion. So here I can right click and I will add the circle again. Let's say for a radius of 0.1, and it could be like centered at the different location. So let's say it is different placed at the 1.5 center. let us build selected. And here I can create with the help of rotate operation. I can create the array out of it. So here you can find the rotate operation. I can select this box. Let's say the angular rotation should be start from the 0. It should have step of, let's say, 360-degree, but as per the end requirement, n is going to be get changed equally distributed. And let us click on the pre-selected. So now in the circular fashion, I have created my geometry. In the latter stage, if I now increase, let's say the part value is nothing but the 2. In that case, I'm having the linear operation, linear circular arrangement. If n value is getting increased, let's say the 8. In that case, as it is n value is greater than 4, so it will execute, it will disable this if statement, and it will execute the if to condition, and we will have the circular arrangement in of 8 number of circles. I can also create the multiple instance while creating my geometry. So I can call this geometry as the part 1. So this is nothing but the part 1 labeling. I can here define, let's say the first part is having n as a 2. I can define here itself. Then the second instance, I can also call it multiple times. If I go under the parts, and here the parts, let's say n value is nothing but, let's say I want to have nine circles, but it should be displaced by having the center of 1. So I can displace it, or let's say the displacement of 4. So here you can see I have created my geometry, multiple instances. And suppose if you want to create the selection for it, in that case, here at the time of defining the circle itself, I will have the instances. So let's say if the n value is 2, in that case, this geometry will be created, and these circles are nothing corresponding to the air itself. In that case, I will have one selection, which will, let's say, called it as the air. And if it is in circular arrangement, I can consider another selection. Let's say if it is in circular, then I would like to have it for the silicon. So suppose if I go here, now you will let me create the part instance one more time, and you will find all these nodes which are available. So if I go under the part 1, let's say with n equal to 2, I have built my geometry. Then let me call again this part instant with the help of 1 again, and here let's say 9, and the displacement is of 4. So here you can see we have created the geometry. Now I can create the domain selection. Suppose I would like to have domain as well as the silicon selection for it. In the second instance, I would like to have the silicon instance for it. So definitely I can add this. And while applying the material, I can easily use this selection. So suppose I would like to apply air material. In that case, I can easily select the air. And in this way, in a one go, I have applied the air material. Of course, you will define the material properties as per your requirement. In the latter stage, if I would like to apply this domain condition, these material properties for this silicon instant. So definitely you can also apply in a one go by creating the cumulative selections here itself, and later enabling it for for uh, for to get the visualization. Okay, so with this, the second part comes into the picture. So here you will find the many of the operations, the programming operations. Here only the if and if conditions are available. But if you are dealing with the complex geometry, so such as if you want to build the concentric circles, let's say the annular rings multiple times. So in that case, how you can do? So of course, for that instance, we also have the method editor tool, and here you can go with the help of application builder. You can convert, you can create the geometry also as per your requirement. So for that, let me create another instance. I'm dealing with, let's say, the 2D object. So here my goal is to create annular rings for multiple annular rings at the center of 0, 0. Here, let's say I'm defining the radius factor for it. So radius factor A. So let's say it should be 1. And in the similar fashion, the radius factor B. So with the help of this, I can create my, so let's have 1.2. And here I would like to consider create my geometry with the help of, let's say, radius factor A, and the second consecutive radius uh, circle should be like radius factor B, but should be multiplied by the 2. So here you can see I'm creating, and as it is the repeating task, I can also create this geometry with the help of method environment by creating the code for it, by writing the code for it. I want to create, let's say, 30 number of, say, 30 number of circles which have the alternate radius. Let's say the radius factor A, and another radius factor B multiplied by 2. Another instance, let's say a radius factor with 1, but multiplied by 3. So here I'm creating the additional circle one and one more time. But of course, creating these circles many a times become tedious tasks. In that case, definitely you can go with the uh, apply method builder section. So add the let me let me add this circle. Let me create this method for you. So I can go with the application builder. Here I will go on the method builder. So here you will find the let me reset the desktop, and here you will find the new method. I can also create the method one, and here I will write some set of codes to execute my statements. So I can also use the language elements. Here you will find all these elements. It could be like block statement, if else, or it could be like conversions, array, matrix, scalar conversion, that definitely you can use. So let me create one simple way how we can generate this coding statement also. So here under the home, if I go to my developer session, so here you will find under the application. So give us a minute. So yes, so if after writing some executable code under your method one, let's say it could be consist of the statement, if else statement. So here I can double click on this, and here you can write the true condition and false condition. And of course, you can use some of the inputs if it is required. Let's say here I'm providing number of values yens, so that will be the number of circles. So it could be like integer, and later I can use this n value while writing my codes. And here one such example I have already created. under the application builder, you will find that I have written the code for creating the circle. So let us understand this one by one. Suppose here I'm using the for f value. If f equal to 1, f should be always less than n. So maximum times n, this statement will getting executed n times. And if it is the odd value, in that case this condition will get satisfied. And if it f value is the even, in that case this condition will be get satisfied. And here I'm writing creating the circle c1 with having the radius as the radius factor a in condition 1, and in the else condition I'm creating the radius factor b with the help of executing the else condition. And that's how I have written my method 1 statement. So here I have also defined by default value for number of circles that I'm interested in, that is nothing but the 5. If I go on the model builder, so under the global definition you will find the method calls. And here I can call this method 1 which I have just created. So after adding this, you will find the method 1, and I can execute this. So suppose if I want to create the 40 circles, in that case I can write n equal to 40 and I can execute my method. And in a one go, I have created the 40 circles which has the radius, let's say radius factor 1, radius factor b, radius factor b, radius factor a, radius factor b in alternate fashion. And thus I have created my annular ring. This method application can be typically used when you are dealing with the by dealing with the geometries which has some pattern to be followed. Another application we do have is the partition. So with the help of partition operation, you can you can create the structured mesh. So so here, let's say I have created my geometry, I have imported my geometry, and I want to create the structured mesh. In that case, let me show you. Let me show you the. Let's say I have imported this geometry, and to have the optimize my resource environment, so I can always go for my structured mesh. And if you see, I can also I'm not able to do this structured mesh, but I'm free to do the free tetrahedral meshing. But suppose I want to create the meshing which is actually the uh, structured mesh, which reduce our let's say the computational time by optimizing our meshing requirement. So how we can create that? With the help of partition object, definitely you can add another partition. And here, as the cross section was different, this object will not have the structured mesh as I have just shown to you. So as the cross section is not uniform at the top and at the bottom, so here we are facing the issue while creating the swept mesh. But nevertheless, we do have the option for the partition object. So here I have added the work plane, and let me enable it. And here I have chosen the face parallel option, and the face that I have selected where this object needs to be partitioned, the face that I have selected. Let us click on builder, and I have added the partition object. So here you can see under the Boolean and partition, you will find the partition object operation. So here I have created the partition object. Let me click on the builder, and let's create the mesh, this web mesh. So now you can see easily see, we have created the Swift mesh just by creating the partition. This partition is also useful while where you want to have refinement in your physics, where the dependent variable is varying drastically. So there you can resolve your mesh finer one. So definitely this partition operation is also helpful. Another operation that could be used is the conversion. You can go the surface that you have, you can also give the thickness to it, or you can also create for the thicken object, you can also create the surface out of it. Various CAD import options if you are dealing with the CAD files that are available. If you are importing the CAD file into the COMSOL environment, you will find we have, you can import the solid surface, solid block of your CAD environment, or you can also import just the surface of it. You can provide the absolute or relative tolerance as per your requirement. And automatic repair feature is also available to heal the gaps, removing the spikes, short edges, silvers, etc. So these are the additional features which are provided with the help of CAD import module and the live products for CAD, as well as the design module. With the help of design module, you can do the fillet operation, chamfering operation, lobed, mid-surface, thicken operation. The ECAD import module is also there to import your ECAD file. Let's say if you are dealing with the GDS file format, the layered by layered geometric also you can import into the COMSOL environment. Other various other options that provided by the to clean up your CAD geometry, such as the delete faces. So here the delete entities option is also present, but delete face is provides actually heals up the gap, as here you can see. So here is the gas channel you can see, and as this gas channel is present at the surface, you cannot delete this gas channel with the help of delete entities, but with the help of delete faces you can easily delete this gas channel which are present on the surface. Next feature could be, which is very useful to identify the spikes or any smaller error with the CAD import module, that is the check feature. You can also detect the interference of imported CAD geometry, and it can be removed as per your requirement. You can also perform the virtual operations on your geometry. These virtual operations will take care by at the time of meshing. So suppose here you can see the edge is present at the intersection of this main gas exhaust, and here you will find this main gas exhaust is here you will find the finer meshing, which is not typically the requirement while handling the physics. So in that case, you can add the ignore edges, you can select this edge, and from the meshing point of view, it will be get ignored, and you will have the far smoother meshing at, at the desired location. The reverse is also possible, and it is advisable to use this operation cautiously so that your physics is not affected. With this, I would like to go for the final demonstration. Here, uh, I will I'm going to have the partition object. So let me uh, go for my geometry. So let me open my uh, presentation itself. Okay. Uh, so in the meantime, definitely we can answer some of our question. So So there is a one question regarding if nodes are do not match with the contact interface, how do we impose the friction condition? So definitely you can have the contact pair feature, and this contact pair feature will take care of while applying the friction condition. So yes, with this, I also have my geometry is present with me. So let me click on, this is the initial geometry that I have. So first of all, here you can see uh, the spikes which are present, which is are unnecessary. So here you can see, so here you can see these spikes are present. I can also merge these spikes by creating, by easily going under my geometry. And here is the cleanup and remove details feature. I can click on the build all, and so let me showcase this feature for you. So here, let me click on the build all. So now here you can see the edges has been removed. Let me click on the this also disabled. So here you can see in the initial stage, the geometry has the additional edges which are very close to each other. But by just adding the remove details, here I need to get rid of the short edges, small faces, silver faces. I can also define uh, the this mode of operation could be like automatic or manual. So definitely I can click on the remove details, and with this we will get rid of the get rid of the small objects. We can create the explicit selections. So here by creating the selections, I can from the physics point of view, let's say I am dealing with the turbulent flow. So here the flow is going to happen with this volume, but the geometry that we have imported doesn't have any volume at all, but through which the fluid is going to be flow. So for that purpose, we will need to create the volume for it. So we can, with the help of explicit selection, I can create the boundaries which I need to be capped this surface so that the volumetric domain can be formed out. I have also created the complement selection. And here, with the help of cap faces, which is actually present under the refeaturing and repair, here you will find the cap face option is added, and all the edges which I need to be capped has been selected. So let me click on enable. It has built up. So here you can see the cap option has been created. Some of the additional requirement adds, as the external volumetric domain is not required from solving the turbulent flow point of view. So definitely I can edit, I can delete that entity. So here you can see I have selected that entity and I have deleted, and I have created my option. So if I want to ignore the mesh elements, so here you can see the additional edges are also present, which unnecessarily add the finer meshing requirement at the given section. So I can also ignore the edges. So the edges that I have selected with the help of complement selection, and I have removed. And from the mesh point of view, all these nodes has been removed. So this is the meshing requirement. If the edges was if the ignore edges was disabled, so here you can see the meshing edge elements has almost 1000 close to the 2000. But if I click on the, if I enable on the ignore edges, and let me delete some of the edges, ignore the edges from meshing point of view, and here you can see under the message box, now the meshing the edge elements corresponding to the mesh has been reduced drastically, and definitely it will reduce the it will reduce the computational time for from while handling the physics. At the same time, we have maintained the accuracy also. So note that we need to select the ignore edges very carefully. Which edges need to be selected, which will not, which doesn't have the effect while handling the physics. So having said so, we are open for the question answer session, and let me go quickly through one by one. So there is one question regarding uh, there is a question regarding why the mesh is getting overlapped in the case of form assembly. So yes, as I was talking about, so meshing uh, the form assembly provide the flexibility to the user to apply the boundary condition as per your requirement. And this due to this flexibility, the meshing requirement is also different, and that's why the overlapping here you can observe. Then there is a request how to create the geometry from the from the equation. So yes, it is also possible. So let's say I'm dealing I want to create uh, I want to create one additional component. Let's say I'm adding the 3D component, and here I would like to create the this the spiral geometry with the help of equation. So here you can see the parametric equation, curve is also available. So here you can provide the variation that you are interested in. So it could be from the 0 degree. Uh, that parameter is varying to, let's say, 360 degree, and here the x variation is uh, nothing but the cos of s. Y variation could be like sine of s, and let's say uh, it is s. So here you can see in a very easily fashion with the help of equation I have created my spiral geometry. So definitely with the help of parametric curve, you can create uh, the object as per your requirement. Then there is another question: how to deal with the selections when you include a part into a part. So definitely you can contribute this selection to any of the things. So suppose the circle one is corresponding to the part one. Let's say this is circle one is nothing but the air, and now I'm also interested circle two should be part of selection of the air. In that case, instead of creating new, I will go under the none and I will contribute it to the air. So at the time of applying the material, or it could be like boundary condition. So if I select the domains, and here I can select the air material itself. So in this way, I can contribute. I can also have the selection which includes different parts. So yes, there is a question regarding, can we import the STL files? Yes, COMSOL Multiphysics do provide the import for the STL file. So here, if I go to my COMSOL website, so under the product information, or if I go at the bottom, you will find the specification. You will find the specification chart, and under the specification chart, you will have the CAD specification chart, and This CAD specification chart will tell you which file format will be supported by the different method, different modules. So under the meshing size, all these file formats can also be supported. So yes, uh, these file formats are actually supported. Then, so there is a question: if I want to tilt some geometry, yes, tilting feature is also available. Suppose I want to tilt this object. So yes, let's say this block I'm interested in tilting. So I can go under the, let me check the rotate operation. So here under the geometry, you will find the rotate operation. Here I can choose this object if I want to rotate. And if I want to rotate along the z-axis, I can also choose the degree. Let's say it could be like 30 degree. So now very easily I have rotated it along the z-axis. And definitely you can choose the axis of your rotation. It could be like x-axis or it could be like y-axis. Everything can be doable. So yes, with the help of rotate operation, definitely you can do. Then so So yes, we are now at the closer of the session, and there are of course some of the unanswered queries as well. Definitely, we will answer these queries with the help of support platform. Uh, or if you are interested uh, to uh, to know more about the best practices, definitely you can write to us at the support@comsol.com, and we will take care your query from the support platform. Thank you for attending this session. I hope this session was useful for you. Uh, and yes, thank you. Thank you, one and all. Have a good day.